Okay, for this question, we have a velocity time graph calculation here. It said a motorcycle accelerates from rest for 10 seconds up to a velocity of 20 meters per second. Then it said it continues with uniform velocity for a further 20 seconds and then decelerates, so it stops in 20 seconds. Calculate a acceleration, deceleration, and then distance travel. The first thing I want you to get attention to is, let's check how long does this entire journey last. To discover that the first journey was for 10 seconds and then 20 seconds, then you have another 20 seconds. So the total time taken for the journey is what? 20 plus 20 plus 10, that's 50 seconds. So this is a 50 seconds journey. And then another thing I want you to discover is that the maximum velocity, that means the highest velocity in this journey, is 20 meters per second. So that's the maximum velocity, 20 meters per second. So, but now the secret in this thing is, if you try to understand it, you just need to break the journey down pass by pass. So I've already put forth a video on how to identify whether the car is accelerating uniformly or constant velocity or uniform deceleration or retardation. So I'm going to put the link in the description, but if you've watched that and you're conversant with those terms already, this should be relatively easy to solve. So I think the most important part of this question is to get your diagram correct. So let's draw the diagram, the velocity time graph. Okay, so remember, we always plot our velocity against time. So we have a velocity there and we have our time. So for the first journey, you see that a motorcycle accelerates from rest. So from rest means that's the point where both the velocity and the time is zero. So the car was not moving then, so it started moving, up to a velocity of 20 meters per second. So it moved to the point, let's call this, it started from zero, it kept moving in this direction, velocity kept increasing until it got to a climax of 20. Alright, so and the time also kept increasing until it gets a climax of 10 seconds. So from this origin, which is 0, up to this point, let's say this is 10 seconds later. Alright, so let's draw the line. So you see that it's going to go in this direction since the velocity was increasing. Right? So that's what we have. Okay, so let's connect the y-axis and the x-axis together. Alright, so what we're saying is simply is that when the velocity is, I think that my line is too much, I'll go to the clean. So when the velocity is 20 meters per second, the time is what? The time is 10 seconds. So this is the first journey. So let's just erase the excess line. Okay, so this is what we have for the first journey. So when the velocity was up to 20 meters per second, it took just 10 seconds to get to a speed, or rather a velocity of 20 meters per second. So this is the first journey. Now we're going to be understanding, what do you think we can find? What's the possible question they can ask us this first journey? The first question could be, what is the acceleration? Remember, acceleration is a slope, right? So if we calculate this slope here, we're going to get the acceleration, and then they marks us the total distance covered. Again, remember that distance covered in the journey is the area under the graph. How do we get the area under that graph? You know that this shape is a triangle, right? So we do have base times side. Remember, this from this point to this point is 20, and then the base is 10. So I want you to just keep these things in mind. All right, so that's the first part of the journey. Now for the second part, it says that it continues with a uniform velocity for 20 seconds. That means the velocity did not change. So at this 20, it kept going that way. So I think I'll use another color. Let me use green for that to show the uniform velocity. So you have from this point kept going for how many seconds now? For 20 seconds. So that's what we have. So at that point the time, so from 10 to 20 seconds, so you have from 10 we enter 20, then enter another 30. So the time there would be 30 seconds later, relative to our starting point, which is 0. So let's connect those lines again. So we always use the blue to connect our y and then our x. So y is still at 20, y the x is 30 seconds now. So that's what we have there. So that would be the second part of this journey. Alright, so you see, what do you think acceleration will be on this second part? Remember, when velocity is constant, acceleration is 0. So acceleration on this second journey, part of the journey, is 0. So we can't calculate any acceleration there. However, we can calculate distance. Distance again is the area under this graph, which it will be the area of a rectangle. That will be length times breadth. You discover that the breadth now is 10 to 30, which is 20, and then the length is still 20. So 20 times 20 would be the area. So let's complete the graph. Okay, so it now says, and then decelerate. So it stops in 20 seconds. So deceleration means the speed started coming down, and then finally it will eventually get to rest. So that's what we have there. The time it took for this process is also 20 seconds. So from 30 to 20, of course, you see that would be 50 seconds. Remember, time is in seconds. So you see that our graph is correct because our total time is still 50 seconds, and then that would be the third side to this journey. And what we can calculate there, of course, you see that when the car is slowing down until it comes to a rest, that's negative acceleration or deceleration, retardation also. So let's now solve. Okay, then let's begin to identify our points. On the first part of the journey, along the y-axis, I mean this vertical, along the y-axis, you see that we are starting from the point 0. So that will be our first value of y1, up to this part, which is y2. And then along the x-axis, our starting will be x1, which is 0. And then, okay, let me just move up a little more. And then our x2 will be at 10. So we can use that to answer the first question for acceleration. So answer for A, acceleration, remember, is the slope of velocity time graph. So it's always y2 minus y1 all over x2 minus x1. So our y2 is 20 minus y1 is 0 divided by x2 is 10, x1 is 0. So we have 20 over 10. So just cancel. So our acceleration A is 2 over 1 is just 2, so 2 meters per second squared. And you see the value is positive because whenever acceleration is positive, it means that the body is speeding up, but especially provided the velocity is also positive. So our acceleration is positive 2 meters per second. Now the next one is deceleration. Of course, deceleration is on the third part of the journey because that's when the car starts slowing down. So for deceleration, we're going to mark the points again. You see that when the car is decelerating, that means we are starting from this point to go down. So that will be our y1, which you can see the value is 20 there. And our y2 will be at this point, right? You see that is the point where the velocity is 0, because for the car to come to rest, velocity has become 0 again. So you see that will be our y2. And then x1 will be just at 30 there. So I'll just write it on the x1, and this will be our x2. So for the B part, deceleration, which we also represent as A, will be equal to y2 minus y1 all over x2 minus x1, which is equal to the value of y2 there is what? 0 minus y1 is 20 divided by x2 is 50, x1 is 30. Okay, more room. So deceleration now is equal to negative 20, because 0 minus 20 is negative 20. 50 minus 30 is still 20. So 20 will cancel 20. We have negative 1 meter per second squared. You see, that's what we call deceleration, negative acceleration. So when you see negative attached to acceleration, it simply means that it's slowing down. So that's retardation. Okay, then the next question there, C part, it says we should calculate the distance traveled. So the distance traveled in the journey, that's what we want to calculate now. Now recall that I said that the distance is the area under the graph. So for the first journey, that's the area. So we can calculate these areas individually. You can also calculate it as a whole, because the whole graph is forming a shape that is a trapezium. So we can just calculate the area of a trapezium. But don't worry, I'm going to solve using the two methods. So I'm going to calculate it first. So I'm going to say the distance covered will be the area of the trapezium. I'm calculating everything together, and then I'll calculate it separately and see whether we get the same thing. So area of trapezium is given by half bracket a plus b times height. Again, I've derived this formula in a previous video, alright, on areas where I calculated the we try to derive all the formulas for solving area of plane shape. So I'm also going to drop the video or the link to the video in the description. So remember, this AB are the parallel sides, which is this side on the X and this other side. So what are the values of that side? So what's the value for our A? I mean, from this equation now. So okay, let's call this side our A, let's call this side our B. So A is the distance from that green line, or that our constant velocity. So if from 10 to 30 is 20, that means A is also going to be 20, since that is kind of a rectangle. So our A is 20. Now what of B? B is the other side, which is just the full x-axis. So you see, you start from 0 to 50. So B will be equal to what? 50. Then what's the height? Of course, the height is the distance, right? The vertical distance, which is 20. So h is equal to 20. Now let's solve. Okay, so our total distance covered will be 1 over 2 brackets 20 plus 50 times the height, which is 20, which will be equal to, okay, let me not do that. So we have our D equal to half times 20 plus 7 plus 50 is 70 times 20. So 2 into 20 is 10. So 70 times 10 is 700. So the journey is 700 meters. I prefer this method because it's very fast. But just in case you want to break it down, so we're going to break it down this way. Okay, so for this first journey, that first journey that represented with 1, the area will be the area of triangle, which is half base times height. The base is from 0 to 10, so the base is 10, the height is 20. So let's calculate that one. So D, we're going to call it D1, which is half base. Base, we got that 10, and the height is 20. So if we cancel out, we have 10 times 10, which is 100 meters. So D2, let's go back to our diagram. You see that D2 is this rectangle, right? Everything is looking stuffy, but just try to follow this rectangle. You see that the base is 20, which we solved before. Not really base, the breadth now, right? The breadth. So actually it's a square, because the breadth is 20, and you see that the length is also 20. That's the y-axis from 0 to 20. So the whole thing is a square. So that's 20 times 20, right? That's area of square. So we have 20 times 20, which is 2 times 2 is 4. You just add your zeros. So you have 400 meters. And then finally, for the last phase, D3, the distance covering the last journey, right? Sorry. So the distance covering the last journey, you see we have this area, which is a triangle. So that would be half base. The base is from 30 to 50 is what? 20. And then the height is 20, right? So, well, the area should be the same with the other one, since, so we have times base is 20, height is 20. Okay, the base is different, so 2 here is 1, 2 into 10 is 10. So we have 20 times 10 is 200 meters. So the total distance rather is going to be D1, which is 100, plus D2, which is 400, plus D3, which is 200 meters. So 100 plus 400 is 500. 500 plus 200 is still 700 meters. So you see, regardless of which path we decide to take, we're still going to get the total distance traveled as 700 meters, and that's it. So velocity time graph is a very simple concept. Just understand how to break the journeys down. If you're still learning how to solve, I think that's the best way to start. But if you already know, you're familiar with everything, you don't necessarily have to just solve everything straight. So I believe this video was helpful. If you enjoyed the video, give it a thumbs up, like it, share the video so that others can see that. Subscribe, tell your friends about